Hello guys, quickly let's look at the terminologies associated or related with kinematics. Now in the previous exposition we looked at motion as a whole and we discussed the various branches motion is divided into. Now we'll discuss kinematics and kinetics, and also we mentioned things like the equations of motion. We derived all the equations of motion, and today we're going to be looking at other terms that we have to know before we go directly into calculations on kinematics. And don't forget, we're working on rectilinear motion under kinematics. Now today we're going to be looking at, first we're going to be looking at what we call average or mean velocity. Now when we say average velocity or mean velocity, what does that mean? It is simply the rate of change in the displacement of a body. Now average velocity, or as we call it in mathematics, we could call it mean velocity. It simply means the rate of change in the displacement of a body. Now don't forget something I said in the previous exposition, that velocity is different from speed. Now in what way? Now velocity is a vector quantity, while speed is a scalar quantity. So as you can see, average velocity or mean velocity, as you can see this V is very dark, it's emboldened, or we have an arrow on it. Average velocity, this average velocity here. This symbol here is one of the Greek symbols, it's called delta. So this is delta S, or change in S over change in T. The S here is displacement. Now displacement is almost the same thing with distance. Now the difference is displacement is a given distance covered in a given direction. So for displacement, we are talking about specific direction. But for distance, there's nothing like that because it's a scalar quantity. Time also is a scalar quantity. So average velocity is change in displacement over change in time, which is final displacement, which is displacement 2, minus displacement 1, which is initial displacement, over final time minus initial time. So that is that for average velocity. Now most times people mix it up with average speed. So quickly, let's see average speed. What's average speed? Average speed is simply the ratio of the total distance traveled or covered by a body to the total time taken to cover such a distance. Now, don't forget, speed is a scalar quantity as said up there. Now, that's the big difference between speed and velocity. So for average speed, it is always the total distance, for example, distance 1 plus distance 2 plus distance 3 plus distance 4, distance 5, and so on and so forth, up to the nth distance over time 1 plus time 2, time 3, time 4, time 5, and so on and so forth up to the end time. Now don't forget this, these can't really be done for average velocity, this average speed you're talking about, although many times people mix them up, So also average speed could also be, just like normal mathematics, the total speed over the number of speed, more or less like speed 1 plus speed 2 plus speed 3 over the number of speed, like speed 1 plus speed 2 plus speed 3 over 3. We give us the average or the mean speed. But most times it's often be mixed up with average velocity. So there's a clear or a conspicuous difference between the two of them. So the next we're going to be going to right now is average acceleration. Average acceleration. Now average acceleration also is a vector quantity just like velocity. So average acceleration is simply the rate of change in the velocity of a body. So when we talk about average acceleration, it's a vector quantity, not a scalar quantity. So this is average acceleration is change in velocity over change in time taken. Now change velocity is same thing as final velocity minus initial velocity over final time taken minus initial time taken. So that's that for average acceleration. Very much like average velocity or mean velocity. So the next thing we're going to be looking at right now is what we call the constant or the uniform velocity, or it could also be constant or uniform acceleration or constant or uniform speed. Now when we say a velocity, acceleration, or speed is constant, what does that mean? It means we are talking about consistency. So look at this. This is simply a phenomenon whereby either an acceleration, speed, or velocity maintain the same output over time. So when we talk about constant or uniform speed, velocity, acceleration, we're talking about the speed, velocity, or acceleration being the same over a given time period. That means there's no change. We're going to be seeing that when it's time for us to work on velocity time graph and so on and so forth. So you're going to be looking at that. So that's that for constant or uniform speed, acceleration, or velocity. So the next thing we're going to be looking at right now will be instantaneous velocity. Now, this is just a major word, an English word. If you look at it, instantaneous, it means the velocity of a body at various instants. That's how a layman would define it, and that's also how I want you to understand it, apart from all this mathematical representation. So let's see. This is simply the velocity of a body at every time instant. So yeah, we're not talking about the cumulative velocity of a body. We're not talking about the velocity over a given time period. We're talking about the velocity of a body at that very given point in time. So instantaneous velocity, which is velocity per time, as you can see, velocity at every point in time, is the limitation. That is when we limit average velocity as change in time approaches zero. We're going to be discussing this. This is under, calculus. This has to do with calculus, So this is we limiting average velocity as time approaches zero, which is equals to change in displacement over change in time. So that's that. So under instantaneous velocity, we're talking about the change in displacement over change in time, even as time approaches zero. So we're talking about that very small, time it takes for us to have an average velocity. So that's what instantaneous velocity simply deals with. So the last thing we're going to be looking at today, before we call it a day, is instantaneous acceleration. So it's simply the acceleration of a body at every point in time, at every given time instant. So very much like instantaneous velocity. So instantaneous acceleration, is you can see acceleration at every time instant. So it's limitation of an average, or the limiting of an average acceleration, I beg your pardon, even as change in time taken approaches zero. So this is simply change in velocity over change in time taken, which is final velocity, that's velocity 2 minus velocity 1, which is initial velocity over change in time 2 minus time 1. So I want you to learn all this because in the next exposition, we're going to be diving directly into all kinds of calculations. So at this very point in time, if you have found this very exposition resourceful, please subscribe to this very channel and share this exposition. Thanks. See you in the next exposition.